Okay, so I'm going to teach you how to do half-life problems right now and what that means. So you're going to learn what is a radioactive isotope, what is radioactive decay, and what is half-life. So radioactive elements are unstable. So what that means is they decay and change into different elements over time. So not all elements are radioactive. Those that are listed below are the most useful for geological dating of fossils. So that means we can tell how old something is by figuring out how much of this stuff there is left. Here are some facts to remember. The half-life of an element is the time it takes for half of that material you started with to decay or to be gone. Each element has its own half-life. Each element decays into a new element. So for example, carbon-14, so carbon that has a mass of 14, is going to decay into nitrogen-14. The half-life of each element is constant, so it's like a clock that keeps perfect time. It never changes. So let's see if we can use half-life to determine the age of a rock or fossil or other artifact. So, the blue grid below represents a quantity of carbon-14. So each time we click, one half-life goes by, and it's going to be red, representing nitrogen. So here we go, one half-life have gone by, and so we only have 50% left of each one. So our ratio is 1 to 1, and that means that 5,750 years have gone by. Okay, another half-life has gone by, 2 half-lives have gone by. We only have 25% of carbon left. We have 75% of nitrogen now. Our ratio is 1 to 3. 11,460 years have gone by. Now 3 half-lives have gone by. We only have 12.5% of carbon left and 87.5% nitrogen left. Our ratio of carbon to nitrogen is 1 to 7. 17,190 years has gone by. And this is how you're going to kind of do problems. And I'm going to step you through a problem next. Here's what that would look like in a graph form. So we would have number of half-lives on the bottom and then how much carbon remaining. And we're doing percent here. You could do grams. You could do something else. So take a look at this graph. And can you tell me what is the half-life of this particular isotope? So we know that half-life means you have half left. So if this is the percent, over here, what is the half-life of this element? So if you said 1 million years, you would be correct. So 50%, 1 million years. Okay, so we're going to do a problem. There's 2 ways to do this problem. I'm going to show you both ways. The half-life of polonium-214, that's the name of the element, polonium with a mass of 214, is 0.001 second. So in 0.001 second, half of it disappears. How much of a 10-gram sample will be left after 0.003 seconds? So one way to do this is just to make a chart like we just saw. So I always like to start at 0. This is the most important thing. Most people, if they get something wrong, they do this wrong. They forget to start at 0 and then they mess something up. So at 0 half-lives, you have the full amount of sample and 0 amount of time has gone by. In this case, time is seconds. It could be years, it could be months, it could be days, but this time it's seconds. After 1 half-life, half of it is going to disappear. So we know that we're going to have 5 left. And we know that that amount of time that's gone by is going to be 0.001 seconds because it tells us. Okay, so we're going to do 2 half-lives now. And we're going to divide our 5 by 2, which is 2.5. And some of this you can do without a calculator, and some of it you might need a calculator for. So we're just going to do the 0.001 times 2 here. So 0.002. And then after 3 half-lives, you're going to have 1.25. I did 2.5 divided by 2, and I did 0.002 times 3. Now, let's look at our question and see if we've answered it. How much of a 10-gram sample will you have left after? So you have the same question, okay? Okay. And then what we're going to say is, okay, so I'm going to read it just again so we can figure out our bearings here. The half-life of polonium-214 is 0.001 seconds. How much of a 10-gram sample will be left after 0.003 seconds? So we can just shorten this a little bit by saying, okay, so we know that 0.003 seconds have gone by. How many half-lives has that been? So the way that we would do that, we would divide. So we would do 0.003 divided by the half-life, and we would get 3. Now we all know that's correct because we just did the problem. So we don't need that last column in our chart anymore. We can just shorten that little bit, but we're still going to do a chart. We're going to divide 10 in half 3 times. And if you can do it without doing the chart, more power to you, but don't forget that you have to start at 0. So at 0 half-lives, we start at 10 grams. 1 half-life, we start at 5 grams, or we divide to 5 grams. 2 half-lives, we divide to 2.5, and at 3 half-lives, we are dividing